This does not need a switch. This is always live. And then these three here are my 96 volts through a switch. What's going on, guys? Just charging this thing up for the top speed and full range test. So I figured I would take a chance to go through something that's pretty quick, but just the overall wiring for everything that is not the big three, the controller, motor, or battery. So I want to run through kind of my 96 volt / 102 volt, my 12 volt system, and where everything runs to, where it all gets power from, how it all works. Starting off, I'm just gonna kind of follow the flow of electricity and like where I'm connecting my main power source and then how that all flows through. So starting off with the negative and positive connections. You'll notice right here, I have a wire coming off that just runs straight to my negative terminal plate right there, my negative manifold. So that's where the ultimate ground terminates. On the other side, pre-contactor, so again, this is my line coming from the battery right here, right? Pre-contactor, coming off of this connection point, I just gone ahead and soldered it into a 6-gauge ring terminal right before my pre-charge resistor. So this line comes off prior to the contactor closing. So if power is turned off, I will still have power coming off of here. So I have my positive and my ground both active with the key turned off. And that runs straight back to, and this is where it's this line right here, start to get a little bit unique. That runs into my 96 volt terminal, and you can see across the top I've connected certain elements of this so that these are all in parallel. This is my 96 volt permanently on power source. This does not need a switch, this is always live. And then these three here are my 96 volts through a switch. How I did that was, I have this line right here, which is in my 96 volt pre-switch. This line runs down to the connection that I made. And this runs up into, you can see that right here, runs into my switch. So if I turn this, it will allow these two to connect, and then it runs back through this black wire here, through here. So these three, power flows from here to here only when the switch is turned on. So these three terminals are only on when the switch is turned. So it allows me to then tap a couple of things off of this. First, I can tap this line, which runs to my DC to DC converters, both wired in parallel here. So I have two DC converters, each with the same specifications. They convert anything from 48 volts all the way to 120 volts down to 12 volts, 15 amps maximum. And so this runs off of here. So when I throw the switch, power goes to my DC to DC converter. So anything 12 volt will not turn on without that switch turned. In addition to that, I have a couple things that run off. I have this wire right here, which runs off, and it is my key power input. What this means is you turn the key on, controller power is on. That's again through one of these three terminals, so that is going to be controlled by the switch. So you turn this on, and the controller power is on. That's one of the lines right here that just goes back to my multi-pin connection there. There's a lot here that is convoluted. I didn't use everything out of this bunch. So there are certain things that when you do a build, you won't need to use every one of these wires. You'll notice there are plenty of them floating around unused. And so in those instances, until I had something that needed to use a CAN sensor in this case, my BMS did not run through CAN. So whatever other communication network I needed to create, I could have used these CAN pins. I won't use them, I don't think, for anything in this build. So there are certain lines that aren't utilized. This one right here goes to my contactor. So if we follow this here, you can see it jiggling. This goes to the positive side of my contactor. I did also wire a diode in there. You can see the negative line faces towards the positive side. You always wire them in for reverse polarity. And then this negative line, we can follow that as well, and you'll see it all just winds up, and that actually terminates right there. And so all of my negatives all come to a common place. That's pretty straightforward. So when I throw the switch, you'll hear it click. I was actually stumped by this for some time because most of the contactors that I've used were on a 12 volt system. So originally I wired it up to my 12 volt side, expecting to, when I throw the switch, to have it click. It didn't click. I thought the contactor is defective until I started reading coil voltage 96 volts DC. And so then I realized, well, I gotta run that through here. So I originally had a relay which isolated everything, made it easy, and then I had to rethink how that works. This red one goes to my voltage meter that I have here. Anything that needed 12 voltage, I wired in through here. And then everything just terminated on ground on this little this little bank here. You can see I just wired those all in so that they run together. And they run below each of those pins that I put in to parallel those groups out. So nothing's able to touch and to short itself out. The display for this here, I'll run through how to program that in a separate video. There's not a lot of information on it, but if you can figure out how it works, it ends up being pretty straightforward. But I needed to have a memory line, which is 96 volts permanently, not switched. And so this yellow, I went ahead and just repinned what they gave me with my own clips. This yellow one here is the memory line. This one is 96 volts through a switch. So go ahead and guess where I ran that to. Right there. So that was pretty, I mean, it just makes it easy once you have those all lined up. Those are my two grounds, so those are grounded commonly in this green line, which goes there. And then this one, it needed a Hall sensor. And actually, this is a funny story. I thought I could just tap into one of the free, because out of this motor come two motor control harnesses. So I thought I could just wire into one of the Hall sensors of this one. Turns out, unless it's the one that's actually controlling the motor, I can't tap into it. So I just stuck it down that waterproof ring until it made contact. And so this actually runs my display when it does RPM or mileage. Sorry, miles per hour or mileage. It's using that Hall sensor to read the rotations of the wheel, and then through a calculation that I programmed in a certain constant for, it's able to compute what the miles per hour is off the back side of that sensor reading. So that pretty well wraps up 96 volts. Things on the 12 volt side, let me run you through how this manifold works. So obviously it runs over through this red line. This is at 96 volts. It then goes into the converters and it comes out as yellow lines, which both tie in here. And so that powers this entire manifold now at 12 volts positive. So anything that needs a 12 volt positive line, I run it off of this. This is actually another line to my display. It's black because they had poor wire color choices. But out of this display, the black line was 12 volt positive through a switch. And so I threw that on there. These two 12 volt lines control my two displays that are on the tank, either the battery temperature or the voltage and amp meter. The controller has its own converter in it, so I didn't need to put anything in that for 12 volt. Yeah, so that really wraps up all the 12 volt. This is the original wiring harness. A lot of this is gonna get removed. It has things like engine sensors, things of that sort that are no longer relevant. So that kind of summarizes the 96 volt and 12 volt manifolds on this. It looks a little bit cluttered, largely because I ran things with extra length. A lot of this clutter comes from the controller cables. Many of these weren't used. Other things that we used, obviously this harness comes pre-connected with everything from the motor that you would need. You can see power, Hall sensors, temperature sensor, thermistor, and from the controller it comes with a matching one that plugs straight in. So that's nice, that's all taken care of. From there, anything else that you want to attach, you can. In this case, that involved connecting the throttle up. So these three come off the throttle. You can see throttle negative, throttle positive, and throttle input. This is the signal line. And so the negative being black, the positive being orange, and the input being yellow. I just ran those to connect to as the colors were defined coming off of that grip control over there. And then on a similar token, we have the drive, the reverse, and the power. So there's actually this black one provides power to the throttle, and then the drive and reverse functions. You just plug those in to the correct lines as they're defined coming off the throttle. So some of this requires you have good documentation. You cannot connect a throttle unless you know what each of those pins goes to. And most of the times the listings that you find from the site that you purchased them from or contacts with sellers, if you get something that's not a well-known throttle, you have to figure out what those pins are yourself. So there's risks and problems that come with that. As with any contactor, you have to have a pre-charged resistor. What this resistor allows is it allows for current to slowly trickle through here which keeps the capacitors in the controller charged up to the point that when you turn the switch, the voltage across those two contacts is not different, at least largely different, and so there will be no arc when that closes. It won't shock me. There's no voltage difference. I will say this is just my solution to the problem. There are plenty of ways to get all of the things that your diagram calls for, and this is just my solving it one wire, one problem at a time solution to this. Someone said I needed a 12 volt positive, so I said, okay, well, let's connect the converters up. Someone said I needed 96 volt through a switch. Okay, well, let's make a 96 volt through a switch, and so on and so forth. Obviously, I knew I needed all of those things when I was originally planning for it, which is why I put this whole platform up here. I knew I would need to have manifolds and arrays of those, you know, certain characteristics and voltages, but I had to rearrange what went where frequently. Originally, I didn't have this manifold up here. Instead, I had 96 volt through a switch, 96 volt, and then I had negatives on some of these, and then 12 volt positive. It got too cluttered, and so I had to go buy an extra manifold that I could terminate all the grounds at separately from each of those. But that's the whole system. I did originally have a little flip switch here like we've used in the past. I just now wired it into this switch here. Works great. We were charging it up, like I said. I calibrated all of that. I'll run you guys through that separately. So that pretty well wraps it up. It's a just ongoing troubleshooting and figuring out what the best way to put things are. I may change where things are located, but that's generally the way that they're lined out. Exactly how many wires we need of certain voltages, things like that. That may change, and as that changes, it changes how I approach putting them on the manifold there. But for the most part, that's the thought process. That's what's where. It's mostly just connecting wires to what they ask for. In order to know that, you have to actually have a diagram that shows what certain inputs are requiring. I'll end the video here, and then I'll catch you guys with some of the more detailed videos coming up second with controller programming and display programming, things of that sort. So I will catch you guys then.